Section 2.6 deals with rational functions. A rational function differs from a polynomial function in that a rational function can be written as a fraction. It is actually two polynomial functions then written as a fraction, one on top of the other. You have a numerator and a denominator. And its general form will look like that. It looks like a lot, but they won't all look this bad as far as the number of terms they have. Just understand that this is the numerator and this one is the denominator. Now, rational functions can take on many different forms. The biggest thing that you have to understand about a rational function is that it is not smooth and continuous. There are going to be some breaks in a rational function. So it could look like this, and then another piece of it would be here, and then maybe another piece here. What they have that's different would be things called asymptotes. An asymptote is a line that a graph approaches but never intersects. As it approaches infinity and a negative infinity. It may intersect it somewhere in here, but as it goes to infinity or negative infinity, it will not approach it, or it will approach it, but it will never intersect it. So in this case, with this particular drawing, we have a vertical asymptote there and a vertical asymptote there. There is also a horizontal asymptote in here. So it looks like that. And there is a y-intercept in this case. The y-intercept, just like the y-intercept in any polynomial function, is going to be equal to the constant terms. Whatever they happen to be. Or just substitute a 0 in for everything and then solve it. Now, to find these asymptotes, you have to know some rules. First, the vertical ones. The vertical asymptotes are the zeros of the denominator. You could say the roots of the denominator. Set it equal to 0 and solve it. Sometimes there may be one, sometimes there may be two, sometimes there aren't any vertical ones. All you have to do is solve it for the variable in the denominator, and any of those places are vertical asymptotes. Actually, I shouldn't say any of them. They could be vertical asymptotes. There are occasions when there isn't a vertical asymptote. Instead, it is called a hole. A hole occurs when you look at the graph of a function, if you want to look at that, starting with it that way. And if you calculate or you figure out the vertical asymptotes and you find that there's supposed to be two of them, and you look at the graph of it and say there was supposed to be one here, but your graph does something like that. And let's say that part isn't there anymore. Say you find two vertical asymptotes, and they're supposed to be there and there. And you look at your graph and it does this thing. Well, it looks like it goes through this point right here, even though there's supposed to be a vertical asymptote. If that is the case, then at this point, there is a hole. Now the graph will not, on your calculator, will look like this, but it really isn't like that. If you blow that section up, it will look like this. There will be a little hole in it. That happens if you factor the denominator and you factor the numerator and you have the same factor in both the numerator and denominator. So for example, if you had something like x plus 4, x plus 8 in your numerator, and then the denominator had x plus 4 and maybe x minus 6, or let's say x minus 1. Because these occur in both the numerator and the denominator, there is going to be a hole at a negative 4. And there will be a vertical asymptote at positive 1. Horizontal asymptotes you have to do a little more work for. You have to know some rules. And to find the horizontal asymptotes, there are three things that have to happen, or three things you have to know. One is if the degree of the numerator, actually the degree of the denominator, is greater than the degree of the numerator, if that is the case, there's a horizontal asymptote at y equals 0. So for example, if you have something and this is x to the third, then down here you would have to have something like 4x to the fifth. Or to the fourth. Then you have y equals 0 as a horizontal asymptote. Second thing that could happen is the degree of each are the same. If that is the case, where the numerator's degree and the denominator's degree are the same, then your horizontal asymptote is going to be the leading coefficient of the numerator over the leading coefficient of the denominator. So for example, if you had something like 3x squared and some stuff after it, and in the denominator it was 4x squared and some stuff after it, your horizontal asymptote would be y equals 3/4, because those are the leading coefficients. The third thing that, and last thing that could happen with the degrees would be the degree of denominator is less than the degree of the numerator. If that is the case, there is no horizontal asymptote. And those are the three different things that could happen with the degrees. If the denominator is bigger than the numerator as far as degree is concerned, then y equals 0 is your horizontal. If the degrees are equal, then you take the leading coefficients, and that's your horizontal asymptote. And if the denominator's degree is less than the numerator's, then there isn't a horizontal asymptote. To find the vertical asymptote, you just take the denominator, set it equal to 0, and find them that way. And then just understand that sometimes a vertical asymptote is not going to be a vertical asymptote. Instead, it's going to be a hole, because there's this factor both in the numerator and denominator. Like I said, most of the time you can just look at the graph and see that there's a hole in it instead of an asymptote. Now on your calculator, when you sketch the graph, or when you enter a polynomial function, you need to make sure that you put the whole numerator in parentheses and the whole denominator in parentheses. Otherwise, you're going to get the incorrect graph. And the other thing about on your calculator is when you graph them, it will not necessarily look like this, because it has to be a continuous flowing thing on your calculator. When you see it, it'll do something like this. This part of your graph would be considered the asymptote. It would be the vertical one. And the orange, or this part here, then it would run like that, really, and like this. And there would be an asymptote in between. But because it has to draw a continuous flowing thing, it can't make that break, so it just draws a vertical line connecting the two parts. Now, here are some examples of rational functions, and we're going to go through and find everything out about them. So the first thing, the y-intercept, in this case, would be 8 over a negative 25. So we know then the y-intercept is 0, comma, negative 8/25, because those are the constants in this case. Horizontal asymptote, we have to look at the degree. Degree here is 1, degree here is 2, so the denominator's degree is more than the numerator's, so therefore y equals 0 is our horizontal asymptote. vertical asymptote, we have to take just the denominator, set it equal to 0, and solve it. And you can either factor it or move it over and take the square root. Either way, you know then that x would equal 5 and negative 5. So therefore, we have two vertical asymptotes, one at 5, one at negative 5. And that would also affect the domain of the function. The domain would run from a negative infinity to a negative 5, from a negative 5 to a positive 5, and then from 5 to infinity. Now you could write it as all reals except for 5 and negative 5 if you wanted to. And there we have all of the information we need, so we could sketch a graph of this. We have a horizontal asymptote at 0, vertical asymptotes at 5 and a negative 5. And we know it crosses at a negative 8/25, which is here. So then the graph probably looks like this. I'm just guessing. Something along that line. And when you draw it, then you could see exactly what it looks like. Our second function here, 7x over 2x plus 8. Y-intercept is going to be constant as 0 in the numerator, 8 in the denominator, so 0, 0 is our y-intercept. Horizontal asymptote, looking at the degrees, degree of this is 1, degree of that is 1, so therefore we have to take the leading coefficient, which is 7 and 2, so our horizontal asymptote is going to be y equals 7/2. Vertical asymptote, take the denominator and set it equal to 0, then solve it, and you will get x equals negative 4. And so since our vertical asymptote is at a negative 4, the domain would be all reals except for negative 4. Sketching the graph. Horizontal asymptote at 7/2. Vertical asymptote at a negative 4. And it crosses at 0, 0. So probably does this. Our last example. Y-intercept. Still going to be 0 over 5. So our y-intercept is 0, 0. Horizontal asymptote. Top degree is 1 bigger than the bottom degree, so therefore there is no horizontal asymptote. And then if you take the denominator, set it equal to 0, and solve, you get x equals -5. So that is our vertical asymptote. And our domain would be all reals except for -5. So we have a vertical asymptote at -5 here. Crosses at 0, 0. So maybe it does something like this. And then the other part of it does something like this, probably. Maybe this is a little bit further down. Probably looks something like that. And those are all the different types of problems you will get. Again, you could also get one that maybe has a hole. That's where this had something up here. As an example. Then it would not look like this. -5, you would solve and get that, but because it's also in the numerator, it would create a hole here, so maybe this would continue down here and do something like that. And then here there would be a hole. Like I said, the easiest way to see that is when you actually calculate the vertical asymptotes, sketch the graph, or put the rational function in your calculator, and then look at it to see if it actually does have an asymptote or if it has a hole. And that is everything that you need to know for section 2.6.